All right, part two. So yeah, we're making a note here. This is just saying that you want to describe in words what's going on. Okay, so we see that we have the slope right here, and you can see it's changing from positive to 0 to negative, and you want to explain what's going on there. If I can get the slide to change here. Okay. So this is kind of an example. It doesn't have to be a long paragraph, but you want to explain in words what's going on. So we're going to say that there's a local maximum at 0, 4. Now, where does the 4 come in? Where do they get that number 4? So when it says there's a local maximum at 0, 4, there's no 4s in here in the chart. From the what? Yes. So if you take 0 and notice in the graph and the equation at the top, if you plug it in here, y equals 0 cubed minus 3, 0 squared plus 4. So that's the point where we knew there was a maximum. It was at 0, but we didn't know the y value. So we plug that in. We say at 0, 4, because y prime is positive for all the x from negative infinity to 0, and y prime is negative for all the x from 0 to 2. So to the left, it's positive. To the right, it's negative. And the slope is 0 at that point. So that's why analytically we can say it's a maximum. Questions? If you're watching and have questions, you'll have to write them down for later. And you'd give a similar explanation for local minimums. So we look at 2, and again, where did they get the 0 from that? What'd they do? They plugged in 2 up above, and so they get the point is at 2, 0, and it's decreasing or negative slope to the left and increasing positive slope to the right, and you're describing the domains where that's happening. Okay, so we're still on the same example. We have the roots -1 and 2 for the original one, and then we have the derivative, and it said possible extreme where at 0 and 2, or. So this is the second kind of way of approaching things. So look at the second derivative. So we've gone from third degree to second degree, and now we're what? What degree? Look at the second derivative. Look at the function, though. First degree. So what would the graph of that look like? Straight line. That's right. That's right. It's a straight line. And so when it's 0, happens at -6. So you could say, because the second derivative at x equals 0 is negative, the graph is concave down. Therefore, it's a local maximum. So you knew it was a maximum or minimum point. And when you plugged in 0, because it gave you a negative number, that means it's concave down. And when it's concave down, that high point is a maximum. Okay, I'm going to ask some questions here. I'm going to pause the video. Well, maybe I'll leave it on. I just plugged 0 into what? First derivative or second derivative? Second. And when I got -6 at the answer, was I more concerned about the 6 or the negative? The negative, that's right. And the negative tells me it's what? Concave down. That means it opens down. The first derivative told me that the slope was 0 at this point. So we know it's a 0 slope, and we know it's concave down, which together tells me it's a what type of point? A local maximum. Exactly. So you're using the second derivative more than checking both sides. So the advantage is you don't have to check both sides. The disadvantage is you need to find the second derivative. So it's not like one's more or less work than the other. Okay, let's see what about the other point. So at 2, right, it's a possible extreme value. We do the second derivative at 2 and we get +6. And which is more important, that it's 6 or that's positive? All right, the fact that it's a possible maximum, meaning that the slope is 0 there, and it's concave up, right? It's the second derivative is positive. It'd be a local what? Local minimum. Okay, this is the last part. We look for inflection points by setting the second derivative equal to 0. So an inflection point would be, where is it changing from a concave up to concave down? So let's think about this. Setting it equal to 0, what would be my x value I'd get? We're all laughing. So if you said something out loud on the video and it was wrong, that's okay. Yeah. So at x equals 1, that's where it's changing from being concave down to concave up. And think about our interval. Where were our maximum and minimum points? What were the x values? 0 and 2. And right in the middle of those is? Yeah, see? So it's concave down at the maximum and at 0. Then at 1, it changes to being concave up. And then at 2, it's the local minimum. We're going to stop that. This is going to be